All right, so now we're looking at a real piecewise function here. We have two pieces. The reason there's two boxes down here is so you have workspace for either. Now obviously this one we need very little workspace for, but that's fine. So let's start with this guy because it seems to be kind of quick and easy here because it's one of those horizontal line things. Notice that I have a scale here that's clearly labeled that tells you that my graph is, or each box is 2. So knowing each box is 2, -2, -4, what's this line?
-5.
-5. So this is the line y equals -5. No real work here, but sure, let's kind of put down here what our thoughts are. Also knowing that this is -2, where am I restricting my domain to? X has to be, yep, -1, and is it less than or greater than? Less than. So notice here I'm going to the left.
Less than or equal to -1.
Notice that I'm going to the left. Look what that looks like here. See, it's also pointing there. Do I need a line underneath my inequality? No. How do I know?
Well, it's an open circle.
Open circle. So let's go ahead and write that piece up here. So I have, again, I wouldn't write y, so I just have -5 if x is less than -1. That's one piece of my function. Now, this might be an example of a time that you may not trust your rise over run business because of the way the scale is set up. So let's pull two ordered pairs out. What's this first ordered pair? X is -1, -4. So let's write this down below. -1, -4. What's another point you see? How about this point since it's our y-intercept?
That's like negative.
What's x?
0.
0, -1. So that'll be helpful because this then is our b value, right? But let's just say when our scale's a little different than the normal, we have a hard time finding slope. And maybe you don't, that's fine. But let's again review, how do you find slope from 2 points? Well, we call our point x1, y1 our first one, which is basically saying the x value of my first point, the y value of my first point. And we call our other point x2, y2. And we know by heart that y2 minus y1 over x2 minus x1 is how we then can find our slope. So we're just really doing direct substitution. y2 subtract y1. -1 subtract
Wait,
-4.
y2 minus y1?
Yeah, doesn't really matter which one you stay with as long as you're consistent. Like if I started here and subtracted that one, then for my x values I'd have to start with that same point and subtract that direction. Doesn't really matter. Over x2 subtract x1. 0 subtract -1. Equals -1 subtract -4. Well, that's like +4, so that's going to give me 3. 0 subtract -1 is going to give me 1. So my slope is 3, and I already know that my y-intercept is -1. So what's my line? (3x minus 1). And there's no arrow, which is insane, but there should be one there. What's the restriction on my domain? X is greater than or equal to -1. Okay, there should be an arrow here. Okay, so let's scroll up. The other piece of my function is 3x subtract 1 if x is greater than or equal to -1. Greater than or equal to because I have a closed circle. Okay, so things you need slope, which is m, and y-intercept. Okay, unless it's a horizontal line. Okay, then it's just y equals that value. So unless, if it's a hoi, then you're just going to have y equals that number. And another thing you need to remember is less than or equal to, greater than or equal to is a closed circle, and less than, greater than corresponds to the open circle. So those are kind of things you may want to keep in your mind as you're doing these. Okay, we're going to do another one together. Another one. Okay, now this one overlaps. You see what I mean there? They both are starting at the same point, so we're just going to kind of choose for one of them to be the filled-in circle, one of them to have the line underneath the inequality, and one of them won't. Okay? So, let's start. I'm going to do this line first, and then I'll do, oops, that line. They both should have arrows. Okay, so starting with f of x equals, a little bracket there. So starting with that red line, can you tell me the slope of that red line just by doing rise over run? Rise over run would give me 2. So that first line, m equals 2. So I'm going to kind of split this so I have space to do both lines. It also gives you your y-intercept, doesn't it? What is the b value? Your slope. So if your scale's 2, so the scale doesn't really matter when you're counting boxes because it would be 2, 4 over 2. Okay?
Unless the scales aren't the same.
Unless the scales aren't the same, right? Like if the x-axis was going by 1 and the y was going by 2, then it would.
Supposed to be a straight line.
It is a straight line. It's the yes. What do you mean? Is it not? It's a straight line. I don't even think I created these graphs. I think they're from a worksheet. All right.
It's 2 different lines? Yeah. Or is it one
Oh,
straight line?
it's 2 different lines. Is that what you mean?
Yeah.
Yeah. So what's my b value? 2, 4, or the 0.04. So what's my first equation?
Y equals
2.
f. X.
Yeah. Then
Plus
what? Plus 4. Okay, so 2x plus 4 if x
is greater than or equal to 0.
0. Great. Now, before we even figure out what the equation for this line is, let's just fill in if x is less than 0, right? So again, it doesn't really matter. Could have been greater than and then less than or equal to because we don't know. We don't have enough information to tell, but just choose 1 because say it asks you to plug in 0, f of 0, you have to have 1. It's going to give you the same value either way. It doesn't really matter. It's the same point. Okay. So let's look at the blue line, or the line I've colored blue. Can you tell me the slope of that line?
Yeah.
What is it?
Rise to 2 is 1.
1 over 1, or just 1. Or if you're using a scale, 2 over 2. What's the b value? 4 again, right? Same point. So what's this line? Y equals?
Y equals 1x. Y equals x plus 4.
Plus 4. So my function is x plus 4 for any values of x that are less than 0. Okay.
Or equal to, right?
So we don't know because it's overlapping. So one of these we will leave open, one will leave closed. It doesn't matter because when x is 0, it doesn't matter which function you choose here. You're going to get 4 because they both are there. Okay. I think that's the American Red Cross, not the phone call I need. Okay. Would you like to do the next one on your own?
Nah, it's alright.
Do you want to do another one together? Okay. So again, again, this is a scale of 2, so these points are actually where x is 1. Okay. So again, let's start by just making our kind of setup here. Ooh, wow. This is where. Okay. Hopefully your bracket's better than mine. Let's do, I'm just going to color code here to keep my work organized. These ones don't overlap. They should totally have arrows though. Now if you want, we can start by just doing the domain restriction really quickly for that red line. It's if x is open circle, going this way, at 1. What would it be?
1.
Greater than 1. So let's now figure out what our line is. So what's our slope? Would you like to do 2 points, or what's the point that's given to us? 1. Halfway between 2 and 4 is 3. And then I drew over this so I can't tell, is this intersecting evenly here at 2, 6? Okay, another point is 2, 6. So if when you're struggling to do your rise over run business, equals 6 subtract 3, 2 subtract 1. What's my slope? 3. 3 over 1. So now, tell me which point you would like to use to find my b value. 1, 3 or 2, 6? Sure. So I know y equals 3x plus b. Okay, I know my slope. I have a point 1, 3, so I can plug in 3 for y and 1 for x, and that's going to give me my b value.
B equals 0.
Equals 0. So I have y equals 3x. That's it. Because b equals 0. So f of x equals 3x if x is greater than 1. It's one piece, yes.
Shouldn't there be 1 negative 3, not 1 3?
I'm on the red line. I'm on the top line.
Oh.
I think
okay.
you're on this one.
Okay.
Okay?
Yeah, thank you.
So the second piece, we could write our domain restriction right away. If x is, now I have a filled in circle going to the left, less than or equal to 1. Okay. Let's pull out 2 points. Is my y-intercept an even value here? What is this? So let's start there actually. What's my y-intercept?
2.
Remember, it's a scale of 2. Negative 4. 0, negative 4 is my y-intercept. Ready? Negative 2, negative 4.
I was just kidding.
Okay. Can you determine your slope without having to use 2 points?
Yeah.
What is it? 1. If you had negative 1, pause for a second, look at it, say, oh, that's going uphill, puff, puff, positive, it should be positive, I need to look at my numbers again.
Y equals x minus 4.
So up here,
X
after
minus
that,
4.
x minus 4 if x is less than or equal to 1.
1.
Okay. I think you have 2 more over here.
We just stop.
Oh, we're not stopping. I'm stopping. Okay. Let's see. So for classwork, you have 2 right here. You should be working on those. For homework, because like I know you practice makes perfect and you just want more, you have these 3. Now, I may suggest you actually flip that because you have to get all of it done anyway. I would say these three are maybe a little bit easier overall, only because it has a scale of 1, and for whatever reason you guys tend to operate it better when that's occurring, whereas these have a scale of 2. Okay? Actually, just do 22 and 23 on here. Okay, so 2 for homework, 2 for classwork, or do all 4 right now. Because we're not going to see something like this on an assessment where we just have like one single, see how it's like not defined here, not defined here? It would just be 1 for
when x equals -1, then
-1, f of x equals -1 if x equals 1. We're not going to see that on our assessments, we're just skipping it. Beautiful.
what do we do?
Well, that's a whole new shebang. We're not there.